Hello and welcome to this latest video in the OCR GCSE Computer Science series, within which we're going to be taking a look at a walking talking mock for the May 2019 paper. So we'll go through the paper together, and I'm hopeful that I can give you the most concise, shortest answers that will allow you to achieve 80 marks out of 80 on the paper. It'd be useful if you had a blank copy of the May 2019 paper in front of you, which you can get from the OCR website. So this is the big picture in terms of Unit 2. These are the key topics which could be examined within Unit 2, and these are the lessons you need to have gone through before attempting one of these papers. So anything that appears there could well come up on the paper we're about to hit on through. So let's get going. Question 1 talks about a computer scientist using a computer and some audio recording software, and it asks to explain how sampling is used to store audio recordings for 2 marks. So the key bit here is you need to make 2 key points. I tend to do that by bullet pointing all of the questions that don't specifically give marks for spelling, punctuation and grammar. So unless it's an essay-based question, which there normally aren't on Unit 2, I tend to bullet point my answers. So what is sampling? Well, the height of the sound wave is sampled or checked at regular intervals. That regular intervals part is important. Each sample is then converted to binary. You don't need to say anything more complex than that. You don't need to talk about bit depth or bit rate. It really is just that idea of sampling the height of the wave and then converting each sample into binary. Part 2 says define what is meant by the term sampling frequency. Now they've changed the phrase there. We normally call that sample rate, but it means the same thing. And again, we're just looking for. So your sampling frequency is the number of samples taken per second or per unit of time. You could also get a mark there for saying how often or how regularly a sample is taken. You'd also get the mark for referring to hertz, meaning number of times per second. We've then got a nice tick box answer. It asks us to tick 2 boxes to show the effects of increasing the sampling frequency. So if we increase the sample frequency, the file size is obviously going to be larger because there are more samples to be stored as binary, but the playback and the quality of that recording will ultimately be better. That one's pretty non-negotiable. Those are the 2 marks. You wouldn't get marks for any other answers. A radio station then uses a digital camera to take a photograph, describe how bitmap images are represented in binary. So we're looking for 3 marks here, and we need to be making 3 points around how images are represented in. So first of all, the image is made up of pixels. Each pixel is then represented or stored as a set of binary numbers, so a binary code, and each binary string represents a color. So if I put a 0 into a pixel, that could mean black. If I put a 1 into a pixel, that could mean white. If I put a 0, 0, that could mean red, 0, 1, blue, and so on. Again, you don't need to write huge amounts there. Notice how little I've written, but I've made 3 clear and concise points, and those are pretty much the 3 that the mark scheme mentions. So the mark scheme says about the image being made up or split into pixels, each pixel's having a binary code, something to do about the color being represented within the pixel being stored within binary. You could also get some marks there for talking about metadata. So you could say that metadata is stored alongside the image. Explain why computers represent data in a binary form. That kind of feels like a slightly odd question. It's not sort of directly related to the content you might have studied. But why do they represent things using ones and zeros? Well, computers ultimately, their building blocks are basic transistors or microscopic switches. And each switch can either be on or off, or each transistor can either be on or off, meaning ones and zeros. We use that to represent binary. So I think that's a fairly tough question there, and one you might struggle to get full marks on. But computers consist of transistors, or tiny switches, and each one of those can either be on or off, and we use our ones and zeros to represent our ones and zeros. Our ons and offs. So the image is then compressed using lossy compression before being uploaded to the radio station's web server. The image will be used on the radio station's website, so that context bit is quite important. It's asking about using it on the web, not printing it, but used on a screen. Describe 1 advantage and 1 disadvantage for 4 marks. So we're getting the name of the advantage or disadvantage and then sort of an explanation or a description. So advantage, file size is reduced, therefore it's quicker to upload. I've made one point there, that's one advantage, but I've made it really clear to the examiner that I'm explaining it. The file size is reduced, therefore it's quicker to upload. You could also say it's quicker to download, so the page will load more quickly, or it's going to use less mobile data. Disadvantages, well, the quality definitely does reduce, and that reduction is permanent. So we can't ever get that reduction back, and that to me does feel like a definite disadvantage. This is a prime example of a question where it would be very easy to get 2 marks out of 4 by saying file size is reduced and quality reduces, but you need to make sure you're getting those 4 marks by describing the advantage, and I've made that really clear with my bullet points. We're then given a flowchart. We're inputting x, we're inputting y. We've then got a bit of comparison. Is x greater than y? Is x less than 12? And some calculations going on based on whether x is greater than y and whether x is less than 12. The table is then given to you with some different input values for x and y. So if x is 15 and if y is 10, what route of the flow diagram do we follow? This one should be fairly straightforward. You're given the numbers, you just need to check, is 15 greater than 10? Is 15 less than 12, for example? And the answers there are 10, 6, 6, and 2. You're then asked to write this in Sudoku. Again, we don't need to go super complicated. Input x, input y, you're going to get marked just for that bit. If you input the variables y and x, you've got yourself 1 out of 6. We know we need an if statement for if x is greater than y, again we're going to get a mark. Then within that, if that's true, we need another if statement, if x is less than 12. Print out the variables with an else statement at the end. Some of you, I think, skip over Sudoku questions because you find those hard. This one is definitely achievable. This is a Sudoku question you could definitely do. You just need to do 2 inputs, 2 if statements, and you've got yourself 6 marks. You've got 10 marks on this page, which is definitely going to take you up at least 1 grade boundary, if not 2. An algorithm is then written in high-level code. Describe 2 methods of translating high-level code into machine code. Well, they are the compiler and the interpreter. Asked to describe those methods. So compiler translates the code in one go and then produces an executable or exe file. The interpreter translates the code line by line, and that needs to happen every time the code is run. So if I created a computer game and I wanted to compile that in the factory and send out an executable file, that would be a compiler. I don't want to send out the code, I want to send out the executable file instead. Something like Python, though, is an interpretive language, and you need to press F5 every time you want your Python program to run, and that happens line by line. Again, those are pretty much the answers for those 2, so if you haven't got that, you're not going to be getting the marks. We're then given some more pseudocode or OCR reference language for the new spec. The program produces a logic error on line 2. State what is meant by a logic error. Logic error is one where the program will run, but it will produce the wrong output, so mixing up a less than and a greater than. It then tells you line 2 has got a logic error, and it should actually be if num mod 2 equals 0 then. So we only want to check if the mod, the remainder, is equal there. So you don't want your greater than or less than, you want to check that value there. State what is meant by a syntax error. Well, that's an error which stops the code from running. So a syntax error is one where you spelled print incorrectly and therefore it's not going to work. On line 5, print odd. They've misspelled print, they've muddled up the N and the T. That one is one you should be able to identify. Print there is exactly the same as Python, so you should be able to identify that print is spelt incorrectly. Elliot then plays football for OCR FC. He wants to create a program to store the results of each football match. Define what is meant by abstraction. Abstraction is removing unnecessary detail not needed to solve the problem so that we can focus on the important detail at hand. 2 marks there, so you need to make sure you're making 2 points. Removing the unnecessary detail is definitely part, my first mark, so that I can focus on the important detail is the second mark that some of you sometimes miss off. Make sure you're making that second point. Then give one example of how you can use abstraction when developing this program. This is a nice, much said in the mark scheme, accept anything that is relevant, okay? Any piece of information that isn't how many goals have been scored and who scored them, you can ignore. So I've put player stats such as age, height, gender, anything like that we could absolutely ignore. We then asked for 2 examples of defensive design which should be considered when developing this program. Okay, so we've got here a program where people are going to type in data, and we know that that can be a problem for security. So we don't want certain characters input. Now you could have here input sanitization, validation, verification, authentication, maintainable code, and then an explanation. I've gone for authentication, so I only want people who are logged in to be able to use the program, and input sanitization. I want to remove special characters such as speech marks to prevent SQL injection. Now again, that's a place we should be able to get 4 marks. Why do we want people to be logged in? Why do I want to check the data that's been input if you were putting validation or verification? That should be a question where you're able to go through and get a decent number of marks. The number of goals scored is then held as an array called goals, and we've got some pseudocode or some OCR reference language that it would like us to complete. We want to check if goals count. So goals count is used as the position variable for this loop. So we go from 0 to goals length minus 1. So count is 0 the first time, 1 the next time, 2 the time after that. It's our loop count variable, and we use that to define the position within the goals array we're looking at. If it's not, then we want to increase goals count. So no goals equals no goals count plus 1. That's just used to increase that. And right at the end, we want to print out the no goals count so that we can work out the matches with no goals that were scored. It tells you in the question, that's what it wants you to print out at the end. So no goals count is definitely line 7. That one is pretty non-negotiable. Those are the answers, so you're going to get that for correct answers only. The only one where there's a little bit of leeway is line 4, so you could put plus plus or plus equals 1 because different languages increase no goals count in a different way. Penalise spelling only once, so if you've messed up the spelling you'll lose a mark, but you won't lose all of the marks if you've just spelt no goals count wrong, but it's clear what you meant. So we're then asked to undertake some hexadecimal to Deanery conversion. Now I understand there are very different methods that different teachers will use to teach you how to convert hexadecimal. I tend to go with the route of converting each symbol, so A and 3, into 4-bit binary. So A equals 10, and 10 is 1010. 3 equals 3, and that's 0011. Join those together and then convert that binary number into Deanery, which is 163. Like I say, there are very different techniques for doing that, so your teacher may have taught you a slightly different route. We then need to convert the binary number 101, 1011 to Deanery. That number means that the switches 1, 2, 8, 16 and 64 are all switched on, which equals 91. Again, you get a mark for your working, so make sure you do put some kind of working down there, even if you don't feel you need to. This is a non-calculator paper, so you're expected to do that level of maths without a calculator. The wizard's hat symbol is then used to mean to the power of. So give the result of a to the power of b when a equals 3 and b. Well, that means 3 times 3, because 3 to the power of 2 means 3 times 3, and that equals 9. 9 is the answer. You don't need to show any working there. The only way you're going to get the mark is if you've written the number 9 as your answer. We're then asked to undertake some binary addition. We should know that a 0 and a 0 makes a 0 and a 1 makes a 1 and a 1 makes a 0 with a 1 carried, and then 3 ones makes a 1 with a 1 carried. Now there are lessons available on YouTube for that, including on my channel, so if you're not sure on how this one works, it's probably best you pause at this point and go and have that. Though should be your answer. You can see where I've carried my 1s, 1 0 1 1 0 1 1 1 0 1. You're then being asked to complete the truth table for the following logic gate. The question here really is, do you know what logic gate that is? That is an OR gate. That means if A or B or both of them is on, then the output is on. Nice easy answer. They're all ones. So you should have a 1 in every single box of that OR gate. An OR gate means if either one is on or both is on, then we put the output Q as on. We've then got our first sort of real big question in terms of taking up the whole page. Slightly scary looking. It's asking us about this function of ticket price, and it wants us to write the pseudocode to create an algorithm for the function ticket price. It's really mean that they've given you so many lines here to answer the question, because that makes it seem like you need to write an awful lot of stuff. An adult costs £19.99. A child costs £8.99, and there's a booking fee of £2.50. So all we want to do is take in the number of adult tickets and the number of child tickets as parameters, and then calculate the total. That's all you need to put. So you get a mark there for your function of ticket price. So have you got some sort of function defined? Def function, function equals, something along those lines. You then get a second mark for the two parameters, number of adult, number of child, but you can call them whatever you want as long as it's sensible. Those are 2 marks we should better get. We then need to calculate the price. The calculation is the number of adults times £19.99, because that's how much an adult ticket is, plus the number of children times £8.99, because that's how much a child ticket is, plus £2.50 for the booking fee. You can do that across multiple lines if you want to, and then add the 2 numbers together, or you can do it within one quite efficient, neat line where we calculate price. Finally, return price, and that again is going to get you a mark. So you should get marks for defining the function, putting in the right variables, some sort of attempt at calculating price, and then the return of price getting you the final mark. Even if you don't get your calculation right, you can still get 5 out of 6 for this question. This is a prime example where you must give it a go. This question really isn't as scary as it looks, and you can be quite sort of neat and efficient with your answer, taking up just 3 lines of the 20 or so available. We're then back to a slightly easier question. Justify your choice of data type for ticket price. So is it a real or a float? And it can be a decimal number. So that should be one we're getting some marks on, because you know that numbers are, currencies can be stored as decimal numbers, therefore it can't be an integer, it can't be a boolean, and it can't really be a string. OCR Land then uses discount codes for customers. Each discount code includes a check digit as the last character. So remember, a check digit is a character which attempts to check that the previous characters have all scanned incorrectly if we're using something like a bar. So it's only asking for 1 mark. It should be nice and simple. It's all about checking that the rest of the code is valid using a check digit. Those are really important in supermarkets where we don't want a cream egg to scan through as a TV just because the wrapper was slightly crumpled up where it was wrapped around an oddly shaped object. We then want to state one reason why a binary search would not be used with the data shown in the list. If ever you get asked why a binary search wouldn't be suitable, is pretty much the only answer. A binary search needs the data to be in order, and if a binary search isn't suitable, it's because the data is not in order. Certainly at GCSE level, that's the only reason you're ever going to get given. We then want to give one, or name a suitable algorithm that could be used with, and the answer is a linear search. We only need to know 2 searches as part of the GCSE, binary and linear, so it's not binary because they told us that before, so it must be a linear search. We're then given some form of algorithm, and it tells us it uses the following bubble sort algorithm to put these queues in order. So we should know what a bubble sort is. It compares 2 items within a list, swaps them around if needed, and then compares the next 2 items, bubbling up through the numbers as it goes. We've got a Boolean variable of swaps, which is identified on line 3 and then potentially changed on line 9. It's set to false to start with, and then sets itself to true if a swap is taken. So that keeps track of whether a swap has taken place within any one loop. and therefore determines whether the loop should continue from line 2. So while swaps is the same as saying while swaps equals true. Basically, if you go through an entire iteration of a bubble sort without making a swap, then the list is sorted. So if the bubble goes right the way up through the list as one full loop and no swap is made, then we can stop sorting because the list is sorted. It makes our algorithm more efficient. We're then asked to explain lines 6 to 8. So we set queue size Q size P, we set to temp, and then we swap queue size P with queue size P plus 1 and set queue size P plus 1 to temp. Why do we do that? We swap the values, temporarily storing P in temp to allow the swap to take place. If I said to you, you've got a ball in each hand, swap them over, but they can't touch and you can't let go of either one at any point, you'd have to put one of them into a temporary storage location, e.g. someone else's hand, then put your left hand into your right hand, and then take the ball back with your left hand. Now again, there are some really good lessons on YouTube around sorting algorithms. If you aren't quite clear on how a bubble sort works, I'd suggest pausing at this point and going and having a watch of those. Describe one way that the maintainability of this program could be improved. If ever we're asked about maintainability, we've got comments, sensible variable names, some sort of modularization, for example functions, or indentation as our option. Now we can't pick indentation here because the code was really well indented. Get any others. So I'm going to go with add comments to explain the purpose of each line. Again, you don't need to write a huge amount. You get a mark for saying the word comment, and you get a second mark for explaining why that might be useful. Again, give names of 2 other sorting algorithms that could be used instead of. Well, there are only 3 on the GCSE: bubble, insertion, and merge. So it's insertion and merge. On to then the final question of the paper, which is our bigger and, if I'm honest, toughest pseudocode or OCR reference language style question. Now from 2021 onwards, you'll be able to answer this sort of question in Python as long as it appears in section B of the paper. Okay, so one ride in OCR land has a minimum height of 140 centimeters to ride alone or 120 to ride with an adult. We want to ask the user for their height. So I'm immediately thinking, even if I just say, hey, what's your height? Height equals input, I'm going to get some marks. If needed, ask the user if they're riding with an adult. So if they're less than 140 but more than 120, well, I need to ask you, are you in with an adult? Then we need to output yes or no, can they ride, and some sort of loop to repeat until 8 people have done this. Now, this is a tough question. However, you getting 2 out of 8 on this question could be the difference between a grade 7 and a grade 8. So make sure you give the early parts a go, even if you are struggling. There's the model answer. We want to set riders to 0 at the start. We want to say while riders is less than 8. Again, I'm getting some decent marks there just for having a while loop in place. Input height, and we then go through our various if statements. It gets slightly confusing because I've in my elif for elif height greater than or equal to 120, I've then got another question and another if statement. But if you've understood the general process of an if statement, you should be able to nest them within other if statements. That's the answer that would get you 8 on that question. But anything above sort of 4 out of 8 is still going to give you the ability to get some really good grades on this paper. Top tip, absolutely give all of the pseudocode questions a go, even if you don't think you'll be able to answer the whole thing. You can get 4 out of 8 there by just having a basic while loop, a couple of inputs, and maybe one if statement. That's then the end of the OCR Unit 2 2019 paper. I hope that's been a useful walkthrough of exactly how the paper is structured and how you can get the easiest marks, if you like, in the most efficient way. There are lots of videos on the channel to support with various questions that came up within that paper, so sorting algorithms, computational thinking, and those sorts of things. If you do have any other questions, please post those either onto Google Classroom or into the comments section below. Thank you very much for watching.